Continuing our review of Chapter 4, you see below the items in an array list may be added and removed at will. You can add in any order, you can remove in any order that you want. Each item has an index number associated with it. Remember, it always starts with a 0. Index values may change if items are removed. In other words, if it was index number 5 and you deleted the first item, it will now be at index number 4. Everything is relative to where you are. If you delete after where you're at, it doesn't matter so much. The main array list methods are add, get, remove, and size, although there is an abundance of additional methods that you can use. If you look at JavaDoc or you Google ArrayList online, you should be able to get pretty good documentation on this. ArrayList is a parameterized or generic type. Nothing more to add to that. Taking a moment here, look through the code, see if you see anything's wrong. It's kind of interesting that they include this in this presentation because it's going to throw you off, but it is something that we loosely covered in previous lectures, so I guess this is a good test of how well you were paying attention. You see anything wrong here? If you don't see anything, take a few more moments and pause. There are mistakes. There's your first one, the semicolon. What happens in this case? So you don't technically need the begin and end brace. So if file size equals 0, semicolon, so if this is true, it will do this. If it's false, it won't do anything else because there's no else in its view. So then it would have run through the code exactly like that. So the system.out.println would always be executed. Now, in this particular case, it'll generate a compiler error because this else doesn't go with anything. The semicolon here ends that, you have a begin statement, and the compiler will just be confused and not know what to do. Okay? This is what it really looks like. So in its mind, you have multiple pieces of code. It's missing an if statement for that else, and the if statement that you do have is one-liner. Another example of it, they really want to show you another example of it. So the right way to code it would have been this. Would have been to take out that semicolon. This is a common mistake, by the way, that people make up above. This is unbelievably common. So the right way to do it, again, would have been to get rid of all this nonsense, have the begin brace right there. Coming back here. What's wrong here? This is another thing that we've talked about previously in other lectures I've given you. But take a moment, pause the video if you don't immediately see it, and then we'll continue. So in this case, is empty equal true? Because you only have one equal sign, it's going to assign the value of true into is empty. Hopefully that's a variable. And what you really needed was an equal sign to do a comparison. And is empty in this case has to be a variable. It should have an open close parenthesis if it was not. Okay? If this was an open close parenthesis, this would have generated a compiler error. But per Java's rules, this is actually perfectly acceptable. It would always evaluate to true in this case, and it would always do the organizer is empty. It's a mistake that you will likely make at some point in your career, as we all have done it, and it's kind of a badge of honor. All right, here's the correct version. Looking at this, do you see any immediate mistakes? Now, in this particular example, I don't know that it's overly intuitive, so I will give you a hint. Look at the indenting. Take a moment. If you don't see anything, pause the video and take a little longer. Alright, so in this case, the code that was written is files.saved is what would have been executed. But the indentation suggests that both of these lines were what was intended to be run. So how would you fix that? You add the begin brace and the end brace to group your code together. Java will always execute the next line of code if there's no begin brace or end brace, assuming it's part of the if statement. Moving on, grouping objects, collections, and the for each loop. The for each loop is a wonderful command, and it's very, very helpful. Main concepts to be covered, collections, iteration, and loops. Iteration. Iteration, we often want to perform the same action on an arbitrary number of times, or on all the objects an arbitrary number of times. So what they're trying to say here is that if I have 55 objects and I want to update the last change state, let's say, I want to do something that's just going to go through all of them. There's a lot of ways I can handle it, but Java put in a really nice command to help you kind of get through it. Most languages include loop statements of various types. There's usually a while, a for, and what some people call a do loop. Iteration fundamentals. The process of repeating some actions over and over again, that's what they're calling iteration. Loops provide us with a way to control how many times we repeat those actions. Depends on the type of loop that you're using. And with a collection, we often want to repeat the actions for every object exactly one time. In this case, here's a sample code. So for every item in this collection, take the current item, put it into this thing called element, and then let me go. Element here and element type. So in theory, this would be a collection of element type. Just to give you context, again, this is pseudocode, it's illustrative, so don't take it for exactly as it's written. Using each element in a collection in order to do the same things in the loop body statement. So here you would have code to do whatever it is that you want to do. Could be sum up values, could be delete values, could be anything you want. Here's an actual example. Files would be an array list of type string. And then what's going to happen is for each object that's stored in files, it'll pop it out one at a time into file name. And then in this case, it's going to print the file name from it. Okay? So to review that, this next section was pretty quick. Loop statements allow a block of statements to be repeated. The for each loop allows iteration over a whole collection. And for each loop, every object in a collection is made available exactly once. Okay? Selective processing. Statements can be nested, giving greater selectivity to the actions. So in this case, let's see, contains a partial match of the file name. So here you have a for, inside I have an if, inside of that I have a system.out. Okay? It's just a simple example that they're giving you. Some issues or things to think about with the for each is it's easy to write. Termination happens naturally. The connection cannot be changed by the actions. Okay? There is no index provided, so in other words, as it's doing a for in a normal thing called a for loop, you would have an index or you'd have a counter. In this case, you don't. You can't stop partway through. We're going to go with that for now. There are ways to interrupt that. It provides definite iteration, aka bounded iteration. In other words, it's going to go through everything. With that, I want to pause this portion of the video. There was a lot to go through in that one. Please take the time to go through for each. Make sure that you understand it. Go through the sections in the book. Because again, this is not the easiest concept, and there's a lot more to this than what you may completely understand.